Hello guys, today we're going to be using the midpoint formula to find the midpoint of line segments point 1 and point 2. The midpoint formula goes as such. We're going to say that that's midpoint, and it equals as x1 plus x2 over 2, comma, y1 plus y2 over 2 as well. Okay, so how we're going to do this, we're going to get the points of the x's, so we can do this. We can name this as x1 and this x2, as well as y and y2. Okay, now that we have labeled our points, we can just plot them in the formula and we can solve as such. We get x1, which equals 3, plus x2 equals 5. We go that over 2, comma. Now we get the y points, and it equals to -4 plus, and y2 equals to 4. Okay. Oh no. Okay. First, we can split this. We'll start with the first fraction, which is 3 plus 5 over 2. Okay. 3 plus 5 equals 8 over 2. 8 over 2 is 4. Okay, you got your first point. There you go. Okay, -4 plus 4 is 0. Okay, 0 over. So there you go. That's where our points are going to be. Okay, same thing with this example problem. We're going to use the midpoint formula, which goes as midpoint. And you can mark these as x1 and x2. Because those are your x points and these are your y points. That's 1. Don't listen to what I'm doing. Y2, okay. Now you can just plot them again in the formula. So you get that. Okay, and here you just solve as well. So -3 plus 6 equals 3 over 2. You get 2. And 2 plus over that, it equals that. Okay. Okay, 3 over 2. You can leave this as a fraction. And 2 over 2 is 1, so you can get that. 3 over 2 is 1. There you go.
We're going to learn how to graph an equation by plotting points. We need to find a set of points that satisfies the equation. So let's say we have the equation y equals to 4x minus 2. To do this, we are going to assign values to x and then find the corresponding y values. So we have our x values here. Now that we know what our x's are, all we have to do is plug them into the equation. Once we're done plugging in our x values to the equation, all we have to do is solve for y. When we figure out our y values, we have our x and y coordinates to each of the sets of points that satisfy this equation. Here's another example. Let's say we have the equation 2x plus 10, so we have to do the same thing. So you plug in your x's to your equation, and there you have it, your x and y coordinates for a set of points that satisfies the equation y equals to 2x plus 10. So here's a third example of how to find points that satisfy an equation. We have the equation y equals to 3x squared plus 1. And here we have our assigned values for x. So we're going to plug in the x value to the equation, and we are going to solve for it. So once we've solved the equation for y, all we have to do is plug it into the set of points. And here we have them. Points that satisfy the equation of y equals to 3x squared plus 1. Now we're going to do that same thing for the equation of y equals to x cubed plus 2. We plug in the x values. So once again, we have solved for y, and we're going to plug in the x and y values that we've gotten. These are all points that satisfy the equation of y equals to x cubed plus 2. So let's say you have the equation 2x minus y equals to 6. You're going to plug in your x coordinate into your x value down here, and your y coordinate into your y value. So for this equation, it's going to be 2x is going to be 2 minus y is going to be 3. Now all you have to do is solve the equation in order to see if the set of points satisfies the equation or not. So I'm going to simplify this equation, which is going to give me 4 minus 3, which is 1, which does not equal 6. Therefore, this equation is not true and does not satisfy 2x minus y equals to 6. Now this one, 4 plus 2, which equals to 6, which gives me 6. Therefore, I can say that the points 2, negative 2 satisfy the equation 2x minus y equals to 6. Now we're going to talk about intercepts, and we're going to use what we've learned to graph the equation of y equals to x squared minus 9. So we're going to assign values to x. Now that we have our x values, we're just going to plug them into the equation. And now, like we did before, we're just going to solve for y in each one of them. So now that we've figured out all of our points, we're just going to plug them in and continue to find the intercepts of the graph. So this is the graph of y equals to x squared minus 9. Now to find the intercept. An intercept is a point at which the graph crosses the axis. It could be either the x-axis, which is this horizontal line, or the y-axis, which is the vertical line. One thing we need to know about intercepts is that for the y-intercept of an equation, x is always going to be equal to 0. And for the x-intercept of an equation, y is always going to be equal to 0. Our y-intercept is 0, negative 9, since that's the point at which the graph crosses the y-axis. Our x-intercepts are going to be negative 3, 0, and 3, 0, since those are the points at which the graph crosses the x-axis. So there we have it, the x and y intercepts of the graph of y equals to x squared minus 9. Now we're going to learn how to test the graph of an equation for symmetry. We have x-axis, y-axis, and origin symmetry. So for the x-axis symmetry, the y value of the set of points is always going to be the opposite. For y-axis symmetry, the x value is going to be the opposite, and for the origin symmetry, both values are going to be opposite. So let's say we have the point 5, negative 3. If the symmetry were to be across the x-axis, we would have the point 5, 3. If it were to be across the y-axis, we would have the points negative 5, negative 3. And if the symmetry were to be across the origin, we would have the points negative 5, 3. Okay, so now we're going to pretend we have the point 3, 1. And we're going to find its y-axis symmetry, x-axis symmetry, and origin symmetry. To find the y-axis symmetry, we need to get the same set of points, but we're going to change the x value. So it's going to be negative 3, 1, and we're going to graph that. And this, it's going to be its y-axis symmetry. Now for x-axis symmetry, we're going to get the same point, and we're going to change the y value. So it's going to be 3, negative 1. And we're going to graph that. So this point, it's the reflection across the x-axis of 3, 1. Now to get origin symmetry, we're going to switch both values. So it's going to be negative 3, since that's the opposite of 3, and negative 1. And we're going to graph that. So this point, it's going to be the origin symmetry of 3, Here's another example. We're going to find the y-axis, x-axis, and origin symmetry of 4, negative 1. So for y-axis symmetry, we're going to get the opposite x value. So here we have a positive 4. That's going to be negative 4, negative 1. X-axis symmetry, we're going to change the y value to its opposite. So it's going to be 4, 1. For the origin symmetry, we're going to switch up. Again, for the origin symmetry, we switch both values. So that's going to give us negative 4, 1. Now we're going to graph the equation of y equals x squared minus 2, and we're going to find the x and y intercepts and figure out if the graph contains origin, y-axis, or x-axis symmetry. So we're going to have our x values here, and we're going to plug them into the equation. And again, we're going to plot these points in order to get the graph of x squared minus 2. So now that we have our equation graphed in, we're going to figure out x and y intercepts, and we're going to figure out if the graph has symmetry. Now our y-intercept is going to be 0, negative 2, which is right here. And since our x-intercept isn't really that defined, we can just put 4 over 3, which is approximately what we have here, comma 0. And we have, since we have 2, we're going to put the negative of it right here. Now we're going to check our graph for symmetry. First, we're going to check for y-axis symmetry. So here we have one of our points, negative 2, comma 2, which is right here. And we're going to look for the opposite, which would be 2, comma 2, and we have that right here. And we're going to do the same for negative 1, comma negative 1, which is right here. And the opposite would be 1, comma negative 1, and we have that right here. But our graph has y-axis symmetry. Now to look for x-axis symmetry, we're going to check the point negative 2, comma 2 once again, and we're going to look for the opposite y value, so that would be negative 2, comma negative 2, and we don't have that in the graph. Now we're going to check the point negative 1, comma negative 1, and we're going to search for the opposite y value, and that would be negative 1, comma 1, but we do not have that in the graph, so we can say that this graph does not have x-axis symmetry. Now we're going to check for origin symmetry. So we're going to check all of these sets of points for their opposites. The opposite of negative 2, comma 2 would be 2, comma negative 2, and we do not have that in the graph. The opposite of negative 1, comma negative 1 would be 1, comma 1, and we do not have that. So now that we've checked all of them, we can say that this graph does not have an origin symmetry. So for another example of graphing by plotting points, we're going to graph the equation of y equals to 3x minus 3. And once again, we're going to do the same thing we've been doing, which is assign x values, and we're going to proceed to plug in the x values to the equation. Once again, we're going to solve for y and then proceed to plug in x and y into a set of points. So once we've found our sets of points for the equation of y equals to 3x minus 3, we're going to proceed to plot them in. So now that we have our points plotted in, we have our graph, and we can figure out the intercepts and symmetry of the line. So our y-intercept is going to be 0, comma negative 3. It's right here. And our x-intercept is going to be 1, comma 0. Now we're going to test the graph for symmetry. First, y-axis symmetry. We're going to test the point negative 1, comma negative 6. So we're going to find the point with the opposite x value. So we're going to try to find 1, comma negative 6. And we do not have that. So now we're going to test the point 1, comma 0. And it is not here. So we do not have y-axis symmetry. Now we're going to try to find x-axis symmetry. So we're going to test the point negative 2, comma negative 9, and that's going to be 2, comma 9 because we need the opposite y value, and that is not here. Now we're going to try to find the point negative 1, comma 6, and we do not have it, as you can see. Therefore, this graph does not have x-axis symmetry. Now for origin symmetry, we're going to try to find both opposite coordinates. So the first one's going to be 2, comma 9, and we do not have that here. Now 1, comma 6, the opposite of these values, which is not here. Now we need to find the rest of them. Once you've tested all of the points, you're going to find that there is no origin symmetry. Therefore, the graph of y equals to 3x minus 3 does not have any kind of...
Furthermore, we're going to be talking about how you can get additional points by just getting the point, 1 point, okay? As you can see here, we have a point on 4x and 1y. So we can label this as our main point. And since we have a slope of -1, we can just go down 1 and 1 to the right, since right's overrun. And you can just do the opposite for the other one. So you go up 1 and you go to the right. Since this has a negative slope, it's gonna be, the line is going to be at a decreasing angle. Okay, in this problem we're gonna be given, we're gonna find an equation for the line with given properties that we have. Okay, since we have a points, we're gonna start with points. We got this line, all right. So what we can start is by finding out the slope. Would basically just rise overrun again. Okay, so you rise to 1 point and you move to the right 3. So this is a positive slope, so it's going upwards. We can put that in here as our slope, and the equation line is going to be given as y equals to, we put the slope times x, and we're gonna find the y-intercept. So basically we go to the, what's it called, the y-what? Here, are you okay?
Axis?
The y-axis. And we can see that the line travels to approximately 1.5. So we can just put since plus 1.5, okay? And that's how you basically get the line, the equation of the line.
A circle is a set of points at a fixed distance from a fixed point, which is going to be the center, HK. X and Y represents the coordinates of any set of points inside of the circle. So the set of points X and Y and the coordinates of the center of the circle must always equal to R, which is going to be the radius of the circle. So by the distance formula, this is going to be our equation for the circle. This can be also interpreted as x minus h squared plus y minus k squared equals r squared. So this is the standard form of an equation of a circle with center HK, which are right here. Now we're going to see the equation of a circle with center 0, 0, or the origin. And this is only if this is a center. So, example number 1. Let's say you have a circle with radius of 5 and the points -3, 6. All you have to do is plug this in to this equation. So we're going to do that. So this is going to be our equation for a circle with radius 5 and the point -3, 6. And here we have another example. Let's say we have a circle with radius 7 and the point -10, 1. And once again, we're going to plug in that to the equation. So we're going to have the equation. So this is going to be your equation for a circle with radius of 7 and the point -10, 1. Now we're going to find the equation of a circle with the origin as a center and a radius of 8. Our equation for a circle with the origin was x squared plus y squared equals r squared. So that's where we're gonna plug in these points right now. So we're basically just gonna have x squared plus y squared equals to 8 squared, which is gonna be 64 basically. That's it. That's our equation. You just switched. Okay, so to graph a circle, this is what we're gonna do. We have this equation, x plus 3 squared plus y minus 2 squared equals to 16. So all we have to do is compare it to the original equation, the standard equation. So we're gonna compare it. This is gonna be negative 3 because the standard equation is x minus h, which would make this a negative 3 in order to get a positive here. So this is gonna be our h, and this is gonna be a positive 2, which is gonna be our k. So this is gonna be r squared. So all we have to do is take the square root of 16, which is gonna give us 4. So there we have it. We have our radius right here and our set of points, which is gonna be negative 3, 2. And now all we have to do is graph. So here we have our graph, and we're gonna plot our set of points, which is our center, and that's gonna be negative 3, 2. It's right here. This is our center. Since our radius is 4, all we have to do is plot points 4 units to the right, to the left, up or down, and that will form our circle. So here we have the graph of this equation. All we had to do was find the center of the circle and plot points 4 units to each side. Now we're going to graph the equation of x minus 2 squared plus y minus 7 squared equals to 25. So we're going to compare once again the equation to the standard equation. This is going to give us the point 2.7, and this is the center of our circle. And we get the square root of 25, which is 5, and that's going to be our radius. So here we have our circle. To find the intercepts of a circle, you have to get your equation and let y be equal to 0. So you replace y with 0. So we simplify that. And this is going to be our y-intercept, which can be simplified further. Variation is how one quantity varies in relation to another quantity. We are going to have y as a direct variable to x, and one number k acts as a constant of proportionality. So in example number 1, we're going to have the monthly payment p on a mortgage varying directly with the amount borrowed, b. We're going to have the monthly payment p to be 6.65 when the amount borrowed, b, is 1,000. Once we replace the variables, we're going to have p equals to kb. Now all we have to do is plug in p and b into p equals to kb, and we're going to end up with the solution to the equation, which is going to be k equals to 0.00665. Now we know what k is equal to, so we're going to have another example where b equals to 120,000, and that's going to give us p equals to 0.00665 times 120,000, which is going to give us 798. In this second example, we're going to still work with the variables of y equals to kx. So y is going to be equal to 85 and x is going to be equal to 172. So we're going to plug that into the equation and solve for the answer. In this case, y is going to be equal to 60 and x is going to be equal to 0.02. We plug that in, and once again we get the result of the equation, which is 3000. Now we're going to look at inverse variation, a relationship between two variables in which the product is a constant. So we're going to have W, the weight of a piece of wood, and L, its length. W is going to be 500 and L is going to be 10. We plug that in and we have K, which is 5000. Now that we've figured out K, we can figure out how much weight can be applied to a piece of wood that is 25 centimeters in length. So we're going to put the 25 in place of the L and solve, which is going to give us 200